AI safely reaches the moon, facing a near collision, risking a debris catastrophe in space. Astrobotic's Peregrine lunar lander concludes tests and readies for launch. The UAE's maiden robotic spacecraft, the Rashid rover, now journeys towards the moon. Its goal: uncover minerals and novel geology. Yet more groundbreaking, it's testing the moon's first AI algorithm. Rashid, launched on a SpaceX Falcon 9 rocket in December 2022, nestled within Japan's Hakuto R lander, alongside NASA's Lunar Flashlight probe. A historic first unfolds as a commercial mission descends upon the moon. And the innovation doesn't halt there. Rashid is armed with a machine learning algorithm, a form of AI, designed by Canada's Mission Control Space Service, MAX. Though not full AI as humans envision, this algorithm signifies progress. Rashid doesn't possess human-like thinking or complex reasoning. Still, machine learning advances in this direction, a tool for automation. The algorithm learns via guesses, adjusting based on feedback, evolution via experimentation. NASA's keen on these results. The goal: utilize machine learning to empower rovers' autonomous decisions, crucial given communication delays to the moon. The moon is relatively close, yet signals take around 2.7 seconds to reach it. Even with relay satellites for Artemis, communication lags exist. This AI experiment is crucial. NASA eyes not just the moon but Mars, outer planets, and beyond. Delay times stretch from minutes to hours. Autonomy could elevate these missions. However, AI's youth sparks debate, especially in creative domains. But in science, starting is crucial. Rashid focuses on identifying minerals and geological features. The process is simple: human-curated images and spectra-train Rashid. Experimentation aids learning, even from failures. Remarkably, this isn't confined to one entity. MAX shares this technology, thanks to Canada's space agency. Ewan Reid, MAX CEO, praises this public domain demonstration. Rashid's lunar stay is short, just a month. It's meant to gather essential data before the sun fades, concluding a significant mark on space exploration, even for the UAE's debut rover mission. On January 27th, satellite monitoring in low Earth orbit captured a chilling scene. Two Soviet objects, a spent rocket stage and a defunct spy satellite, narrowly avoided a collision. They came within a mere 6 meters of each other, well within the 10-meter margin of error for our current measurement capabilities. This kind of proximity is the stuff that gives astronomers nightmares. This entire incident was observed by Leo Labs, a dedicated company responsible for tracking debris and potential collisions in low Earth orbit. The company later confirmed on Twitter that the near miss occurred within an orbital region known for its heightened risk, sort of a bad neighborhood in space. This specific area has a significant potential for generating debris. Leo Labs monitors a mix of breakup events and abandoned objects to identify potential issues like this. But why is this incident so alarming? Well, typically, the distance between floating debris in orbit is measured in kilometers. Companies like Leo Labs carefully monitor this space junk, keeping track of trajectories and orbits. This allows us to provide warnings to our crewed vehicles and space stations. However, in this case, there are two main reasons for concern. First, we need to understand the Kessler syndrome. Back in 1978, NASA scientist Donald Kessler predicted that as time goes on, the density of orbital debris, satellites, vehicles, and stations would increase to a point where collisions become unavoidable. The collisions themselves aren't the primary issue. Minor impacts like the recent damage to Soyuz MS-22 are manageable. The resulting debris from such impacts is usually too small to pose a significant threat and might even go unnoticed. However, as Kessler warned, larger collisions can lead to a cascade effect. Debris crashing into other objects generates more debris, and this chain reaction continues. The result could be an enormous cloud of shrapnel orbiting Earth, reminiscent of the scenario in the movie Gravity. Leo Labs points out that the collision between just these two pieces of space debris could have generated thousands of new fragments. These fragments would have lingered in orbit for decades, if not longer. But a Kessler cascade scenario suggests an even more dire outcome. Some models predict that a full cascade could create a dense field of debris that would persist in low Earth orbit for an extended period. This could make operating in this region extremely hazardous, effectively cutting off our access to this altitude for centuries. While we haven't reached the density predicted by Kepler yet, the incident on January 27th is just one of many close calls in recent years. One of the most significant incidents in recent memory was the Russian anti-satellite missile test in February 2021. Despite international warnings, this test destroyed an old military satellite, generating hundreds of thousands of new pieces of debris. This forced the crew of the International Space Station to take emergency precautions multiple times as the debris cloud passed dangerously close. The aftermath of this event prompted governments worldwide to take action. New legislation was proposed to address the growing threat of space debris and its potential impact on space operations. As of now, we haven't reached the point where Kepler's predictions have fully materialized. However, the near miss on January 27th is a stark reminder of the risks we face as space becomes increasingly cluttered with man-made objects. Updating decades-old space laws, new regulations have been enacted to modernize regulations around space debris. These laws mandate that newly launched satellites must complete their orbits within 5 years. Consequently, several enterprises involved in debris removal initiatives, like NanoRacks, have experienced a significant surge in funding. While it's disheartening that it often takes imminent threats to prompt action on concerns the scientific community has been raising for decades, it's equally remarkable to witness how swiftly humanity can adjust and devise solutions. Various ventures, such as NanoRacks debris reduction tests, Astroscale's magnetic satellite pursuit, and Airbus robot armed with a harpoon, are a selection of public and commercial initiatives engineered to actively and passively rectify the predicament of orbital clutter. Hopefully, these endeavors will begin to ameliorate that issue, as even after a close 6-meter encounter, the folks at Leo Labs may not be able to withstand much more excitement. The year 2023 is poised to be momentous for commercial collaborations with NASA. The astrobotic Peregrine lunar lander, spearheading a wave of missions, aims to prepare future Artemis mission landing sites. After undergoing comprehensive tests, the Peregrine, under development since 2018, has received the green light to journey to Florida, where it will be loaded with 14 payloads. These payloads encompass 11 NASA experiments and will be integrated into the United Launch Alliance's Falcon Centaur rocket for its inaugural flight. The Peregrine aligns with the Japanese Hakuto lander's concept, essentially shuttles that ferry scientific payloads, such as rovers and instruments, to their intended destinations. This aligns with NASA's broader strategy to leverage commercial partners in establishing a comprehensive support structure for significant missions like Artemis. Dubbed the Commercial Lunar Payload Services (CLPS) program, this initiative allows NASA to optimize its budget by concentrating on major endeavors while enlisting commercial entities to tackle auxiliary tasks, including scouting landing sites and piloting new technology. This mirrors the precise objective of the Peregrine mission, which involves experiments to gauge the moon's intricate atmosphere through a collection of magnetometers and spectrometers, despite its lack of a traditional atmosphere. Supplementing this endeavor are components like a rangefinder, novel solar panels, and various tools for surface measurements. Thus, the Peregrine mission appears more as a technological showcase than a focused scientific pursuit. However, the beauty of the CLPS program lies in its diversity. The Peregrine undertaking represents just one in a series of forthcoming lunar voyages. Intuitive Machines, another participant in NASA's CLPS program, is set to dispatch 5 payloads to the moon this year alone. These missions will identify potential landing sites for future Artemis missions while simultaneously experimenting with processes such as extracting potable water from the lunar South Pole. Relying on commercial groups to bolster NASA's lunar strategies is an ingenious tactic. A plethora of skilled engineering teams, separate from NASA's roster, boast innovative ideas. By tapping into these external entities, NASA not only conserves resources but also fosters innovation, paving the way for rapid technological advancement. Anticipation is high for Peregrine's imminent launch. Join us weekly for more updates on topics spanning the aerospace industry and interstellar exploration.